All right. This is Mr. G Math, and I am coming to you live from room 7202, Indio High School. That's right. 8:38 p.m. on a stinking June 23rd? June 23rd. And none of us know why we're doing math at the end of June. So, let's read about this lesson about intercepts, symmetry, even, odd, and intersections. So, x and y intercepts, you know, is where they cross the x and y axes. To find them analytically, an x-intercept, you make it equal to 0, while a y-intercept, you plug in 0 for x and solve. So if you look at example 1, how would you find the x and y intercepts? So to find the x-intercepts, where there's a y, you plug in 0, and then you solve for x. So I took the equation where there's a y, plugged in 0. If I simplify it, it should be obvious that x equals -3. To write that properly, the x-intercept's at -3, 0. To find the y-intercept, where there's an x, you plug in 0. You solve for y. So we're going to add 3. We're going to take the square root. But when you solve a quadratic, the answer can be both positive and negative. So in this case, one y-intercept's at 0, positive root 3, and the other's at 0, negative root 3. If I asked you a question from the last lesson whether this is a function or not, you would say no. So as you write it as a function, you'd get one that's positive and one that's negative. Symmetry. You can have symmetry with the y-axis. Another name we call that is if the function is even. It means the same thing. So if you have symmetry with the y-axis, or you say the function is even, what does it mean? You could fold along the y-axis and one picture be right on top of the other, right? If you fold it over. If you have symmetry with the x-axis, there's not a special name for that. You could also fold over the x-axis and the top would fold over to the bottom. The other one is symmetry with the origin. We have a name for that. And that one is one that is odd. Now, if you have symmetry with the origin, I like to think of it as symmetry with the cross quadrants, right? So quadrants 1 and 3 would have symmetry, or 2 and 4 would have symmetry. If you look at it analytically, if positive x, positive y is on your graph, then negative x, negative y would have to. So an odd function, whatever point you have, if you change the sign of both x and y, that point also needs to be on your graph. Even, odd, and symmetry with the x-axis. What are some analytical tests for symmetry? So for the y-axis, if you replace x with negative x, and you can simplify it, and it was what it was before, then it has symmetry with the y, and we call this an even function. The x-axis, you replace y with negative y, and if you could simplify it and it stays the same, then it has symmetry with the x-axis. The origin, replace x with negative x and y with negative y, and it produces an equivalent equation. This is called an odd. Informal tests, so those are formal analytical tests. Informal quick tests. Substitute a number and its opposite for x, and it gives you the same y value. So if you looked and you plugged in positive 1 and you plugged in negative 1, what should be true about the answer? It should be exactly the same. Same thing here. If you plugged in positive y and you plugged in negative y, so whatever number it is you plug in, it's -2, you should get the same answer. The origin, you substitute a number and its opposite for x. So in other words, if you plugged in, and it gives you opposite values for y. So if I plugged in positive 1 and I plugged in negative 1, you would get opposite numbers. So whatever the y value is, the opposite sign would go with the next one. So those are just quick informal tests. These informal tests are not foolproof. So that means just a quick way to look at it. Think whether other numbers would work the same. If your substitution produces 0, then try another number. All right, turn the page. Do you know, for number 2, if they're even, odd, we're going to use the words even, odd, or symmetry with the x-axis. So if I look here, do you know if it's even, odd, or not? And how would you know? So just because it's cubed doesn't make it odd. So you could have a cube function that is odd, but if I have transformations, that may not be odd. So that's not enough just because the exponent is 3. So if we want to go formal, this is what it would look like. Where there's an x, I plug in negative x. And then I algebraically simplify it. What's negative x times negative x times negative x? Will that be negative or positive? Negative. And everything else would stay the same. And what's negative times negative? What I notice is this, is each term here is exactly opposite. Do you see that? Like 2x cubed, instead of positive, it's now negative. And negative x, instead of being negative, is positive. So in other words, if I multiplied every term by negative 1, they're exact opposites, which makes this having respect to the origin. Another way to informally look at it is look at every term and look at the exponent. Did every term have an exponent that's odd? It will be odd. Did every exponent have an even exponent? It'll be even. But if there's a mix, like 1 is odd, what happens if this was x squared? Then it would be neither, because it's a mix. So if you want to look at it informally, are all the exponents odd? That would make it odd. Are all the exponents even? But if there's a mix, that's where it becomes trouble. Okay? Look at the next one. The absolute value of x subtract 2. What would you say? Another way to look at this is to think of the graph. Is this an easy one to sketch? Yeah. The absolute value of x subtract 2, what does the picture of absolute value look like? And negative 2 just takes the v and does what? Just pushes it down 2. Is there symmetry with that graph? Yeah. With which axes? Y. With the y-axis. And that we would call that an even function, right? How about that one? The absolute value of y equals x minus 2. What do you think would happen there?
The y-axis? I mean x-axis?
What do you think that would look like? It's different, right? Yeah. So if I put in negative y for positive y, right, and simplified it, are these exactly the same? Would they produce the same result? Yeah. So that's one of the definitions to test to see if it has symmetry with the x-axis. We're not going to go into it. It'd be something interesting for you to look at. See, what does the picture look like if you put the bars around y instead of x minus 2? We'll come back to that later maybe. All right. Even odd functions. A function is defined to be even, right? If you plug in negative x and it equals the same as positive x. For all x in the domain, even functions have graphs that are symmetric with which axes? The y. Can you see what's similar about all of these examples? What do you see the exponent, right? What exponent don't you see that's with 3? Right? And it belongs with the even numbers in this case. Because you know what that 3 does? It just pushes something up or down the y-axis, right? So a constant at the end doesn't make it not symmetric with the y-axis, because whatever the picture is, it just pushes it up and down the y-axis, but you can still fold over it, right? And again, what do you notice about odd functions about the exponent every time? They're all odd. Now I'm going to tell you that if you have a constant at the end, it no longer makes it odd. Because if you push that up or down the y-axis, there's no longer symmetry across the quadrants. Because you look at quadrants 1 and 3 or 2 and 4, you push it up or down the y-axis, it doesn't work anymore. So that means if there's a constant at the end, it's not going to be symmetric with the y-axis or with the origin. But notice all the exponents have what number? They all are odd with odd and even with even, right? Not bad. So look at those examples. Which are even, odd, or neither? Number 5 is? Why? All the exponents are odd. 6, even, odd, or neither? Even. And that -4 just pushes it down the y-axis but keeps it even. And 7. Why? Because one's even and one is. So it's a mix. And that mix makes it neither. Point of intersection. Are you able to find where functions intersect analytically rather than typing them into Desmos? So look at these two functions. And they are both functions. How would you find where those two functions intersect? What would you do? So the truth is there more than one way to do this? Yes. Could you use elimination? Yes. Could you use substitution? Yes. You ready? So let's say I look at it and it says, I want to use elimination. Do you know what I would do? I would, if you put them underneath each other, right? Joseph, can you tell me a story, Joseph?
Sure. I'm late. So I was by myself this morning because my dad was at work and my mom was sitting with my grandma. I don't want to say what happened to her, but.
Joseph. So are we good now that you're here with your family? Okay, I want you to answer these 3 questions. You ready? And then we can move on. Joseph, what's the best thing about being you?
I don't think I care about what people think.
What are, one thing, best thing about you?
I think that now I don't care what people think about me, so I'm just like, you know what? I'm going to dance on stage.
There you go, right? Yay.
I'm going to sing on stage.
Yeah, I like that too. I've done that. I was a lead in a musical my senior year. I didn't even tell you that, did I? No, you didn't. That's true.
Musical?
I was a lead in a musical. Not just in a musical, buddy. A lead in a musical. The lead in a musical.
What musical?
It was a Gilbert and Sullivan musical. So I was already in a musical, Pirates of Penzance, and then there was another Gilbert and Sullivan called Patience that I was in. So it was a bit of an obscure Gilbert and Sullivan, but a lot of fun. So, 2. The best thing about being a senior next year, Joseph? Being yourself and being on stage and dancing and singing and being in theater?
Yeah, I'm going to run for drama president.
Awesome. Okay, what's the best thing about NU High?
We have like a family community.
That people love you?
Yeah.
All right, I agree. All right. You can sit together with your friends right there. All right, let's go back to example 8. Joseph, we're all glad you're here.
Yes, we are.
Did you see what I did? I picked the less obvious route just to show you there's different ways to find it, right?
The more obvious route.
I would say to solve for x and then plug that in, use substitution maybe. I don't know. How would you have, when you looked at elimination or substitution, which one would you have picked?
I always use it.
Elimination, yes.
Now, do you think that's, because one's linear and one's quadratic, would that disturb you to use methods of elimination there? Because most often when we do systems, they always are linear, right? We don't think of different functions you could do the same work at. When I subtract, you're going to get x squared minus x. I can't combine them together, right? They just go beside each other. When you subtract the negative y's, they're going to eliminate, and 3 subtract 1 is 2. How do you solve that?
Would you take out the x?
No. How would I solve that? By factoring and make it equal to 0. So to factor it, we must first subtract 2, because you can't solve it by factoring if it's not equal to 0, because that now becomes the 0 product property. You can do this without a diamond, so please don't draw a diamond. 2 numbers that multiply to 2. Yay, I knew you could. An order doesn't matter, right? And what must the signs be so they fit? -2 and +1. Those are not my answers. So if I solved each one, I'm missing an x there. If I solved each one would be -1 and the other would be +2. Does that give me the points of intersection yet? No. What do I still need that I don't have? Now, which one looks simpler to work with?
Negative 1.
The line or the parabola? The line. So where there's an x, what am I going to plug in? Negative 1. There's an easy or complicated way to get y by itself. Do you like doing the easier algebra? The easier algebra is to add y, and then if you subtract 1, what does y equal? So one point of intersection is negative 1, negative 2. Are you at a point where algebra doesn't control you, but you feel you can control algebra? Can we start to get there? That you feel like you are like the boss, and algebra like has to follow your rules, kind of speak. You know what I mean? Like you can become the boss, the Heffa. Is that how you say it? Of algebra. So, yeah. So again, I'm going to do the same work again. Now I'm going to put in 2 for x. Does it make sense that when you draw a slanted line through a parabola, it would intersect at 2 points?
Yeah.
But can you visualize it? A parabola, right? Does it make sense to me that you're going to have 2 points when they intersect, right? So again, what would be good, nice, simple algebra to do here? Add y and then subtract 1, right? And the other point of intersection then would be at positive 2 and 1. Beautiful. All right. Mr. G Math is over and out.